Hello everyone. So in this talk, we'll talk about Prestissimo, a year in path to Veloxification. We already have quite a few talks about Prestissimo, so this will be another. And we'll go through some of the updates from the production setup that we have in Meta. I'm Amit. I'm working as a software engineer at Meta. So the content of this presentation, initially we'll talk about the introduction and the motivation why we started this project, some high-level design, production experience, and what we are planning to do next. So introduction, Prestissimo is the Presto worker implementation in C++. That's the very straightforward answer. And the execution for the Presto worker is done with Velox. It has the vectors, functions, task, drivers, operators, memory, caching, spilling, connector, and table scan, writer, exchange, everything is inside Velox. And then the other end is the verification. In Velox, we have fathers and benchmarks. Outside of that, in Presto, we have verifier, and there is also query banks that will touch what we have now. So the most important question is why we started Prestissimo and what is the need to design Presto worker again. The single most important business reason is to reduce the power consumption and hardware footprint for the warehouse. So basically that means we want to run same workload with significantly less machine. That means more queries per machine or increase in throughput. And we also want to optimize for latency, which is faster query completion time. That is the major goal, the primary goal for this project to even start. And at the same time, since we have the opportunity to start this, we want to develop the reusable components. So we understand that the common eval being used in multiple places, in Presto, in Spark, in AI, ML, streaming, everywhere inside Meta. So we want to unify them and unify the behavior of those things. For example, you have JSON parsing, you have cast, you have regular expression evaluation, different kind of expression evaluations, things have slightly different behavior. And as a company, we do not want to have this different behavior. We want to have the same code running everywhere and can be reused and give the same result wherever we run. So that is common code in many computing frameworks. Improve multiple infrastructures at once. In compute, it's Presto, Spark, Presto on Spark, streaming, AI, ML, learning, existing eval framework that we already have. And at the other end of it, we have run a decade with Presto, with Java inside Meta, and we have seen many JVM problems that scale, at the scale that we operate. There is garbage collection pause, there is tuning when the server gets kind of gets in pause state, so the queries start failing. There's also maintenance on that. And there is, we have the previous presentation that the hardware is evolving and there is SIMD and accelerators. We want to take advantage of those, and most of the databases are written in C++. So in high-level design, this is basically the existing Java worker, Java coordinator, but the new C++ worker, and which acts as a drop-in replacement of the Java worker. There is no hybrid mode, so the worker is completely written in C++. There is no Java, C++ combo, or in a cluster, there is no all the workers in one time. But the worker supports same communication protocol. In a cluster setup, we have single coordinator and multiple workers. And we also have the multiple coordinator implemented, but we haven't tested in our scale yet for C++. And there are multiple clusters in a region. Note that some cluster can be Java, some can be C++, but inside one cluster there is all single kind of worker. The trade-offs we have here is we definitely optimize for performance and hardware, and we also want to have ease of maintenance and reliability, but C++ comes with sec fault as well, right? And at the same time, since it's a brand new eval and the worker, the functionality, all the functionality is not available from the beginning. And there are nuances in function behavior. There will be mismatch because we have existing workload that runs with Java eval, and in many cases, I'll go in forward that the results are slightly different. And at the same time, as a company, we need to maintain both stack for multiple years, and that is also a big cost for the company. So we have to do this very quickly. So in high-level design, these have been discussed quite a few times today, but I'll go quickly. We have the coordinator. The coordinator talks with HTTPS or secure HTTPS with the worker. There is a serialization component that takes the Presto plan and converts to a Velox plan and send this to the Velox to execute, and the result comes back and we return the result. And in terms of code organization, how PrestoDB and Velox communicates is all these serialization, deserialization, plan conversion, query result, and coordinator integration is in PrestoDB, but there is a submodule that points to Velox where the entire eval sits, including exchange, including caching, including spilling, memory management, arbitration, and obviously the eval itself. So now we'll go through how Meta warehouse is divided. So in very high level, they are divided into these three categories. It is from a bird's eye view. There is interactive workload where we have the interactive workload means we have dashboards, applications, monitoring, where the query shape has a lot of variety. They are very latency sensitive, and there are some writes, but not big in size. And there is periodic workload. We call them batch workload. There is also variety of query shapes, but they are very heavy on write. And beyond these two, there is a custom workload. We call this custom because in this case, different customer teams bring their own hardware and run Presto, and because they want different SLA that cannot be guaranteed with the other workload running together, and they have strict performance agreement because they give the hardware to Presto team, and for each of this team has very limited capability to go forward because they are always getting kind of hardware limited by the hardware. And when we build a Presto worker, one of the important part for us is to demonstrate its value in production and running it over the years, reliably maintaining it easily. And so for that we need to find a fast cut of the system that where we can deploy it. Definitely implementing everything is possible, but it also takes time. How can we show the value and then move on top of it, build on top of it? So initially we pick these custom workloads. And one of the major custom workload inside Meta is called Experimentation Platform. They have very complex query shapes, extremely performance heavy, and they are severely limited by hardware, and that is the largest custom workload in Meta. They have large tables, and they are severely power constrained, as constrained that in the regions there is no more plug to add new hardware. And this is impactful use case for Meta, and we have a good relationship with the team so that we can develop the system and deploy and work with them together. So this was our first case, and this also demonstrates that how we also want to demonstrate that the Velox platform is really efficient and serves one of the complicated cases. So this serves as the gateway for the production and demonstration for Presto. So the production criteria for in this case is we want to have Prestissimo for experimentational platform workload. The criteria is support 3 to 4 times of growth without adding more hardware, or reduce their existing footprint by 3 times, which is actually a very, at the beginning we thought is a very challenging ask, although Ori was always confident that we can do 3 times. Then we always want to improve performance. Even with the less hardware, we want to improve the execution time, wall time, and definitely the result needs to be correct. That's what Presto is used for in the company, that the result is always correct. And the stability needs to be much better than the Java worker, which means less failure rate. And at the same time, a good distributed system not only need to be performant, but also need to be very easy to release and maintain. That is very important for us, because otherwise we cannot move the software fast. And that is something we take very seriously. So we need to release with confidence, with very low to no support overhead. And we are very expert in releasing software quickly, and we want to release even a database every week and put the best of the Velox and Prestissimo in production. And we want to know monitoring and understanding of the runtime internals of the software. So this is the criteria with that, and these are some hypothetical query shape that we went with production at the beginning. This is one of the shapes where we have many multiple selects inside, nested selects, and then aggregation in each layer, and then aggregation in the outer layer. This is one shape. This is a similar shape where we do not have many sub-selects, but we have approx percentile outside, and we have aggregates outside. And this is a part of a very large query, but this is also similar to the previous one, but this has an inner join with the sub-selects, and obviously aggregates with variance, approximity, and then group by in each layer. Okay, so once we say implement this thing, how do we know this is better than the Java worker? Not in benchmark, not in like a small benchmark, but we need to understand this actually reduce the Java cluster by half or 1/3, right? That's what we are shooting for. So what we do in these kind of cases, we run real-time shadow between the identical size from Java and C++ workers. And once we see that the C++ worker performs well with the same size of the Java worker, then we start reducing the C++ cluster footprint. We started with 80% less, then we reduced even more, 70% less hardware, did more optimizations. Eventually, we went live with 58% less hardware, and we plan to reach 66% less hardware. Actually, at this point, we already reached that. And in each step, we understood the patterns, shapes, and we made Velox. We made numerous changes in Velox to make sure this can be possible. Some of the highlights for this particular use case, some of the very tricky optimizations we did is we reduced the task status response time for grouped execution. Grouped execution is heavily used in experimentation platform. We resolved the contention of local exchange, and we reduced the hash table size for very low cardinality aggregation keys. We bypass non-reducing partial aggregations. We have developed very state-of-the-art hybrid cache with excellent in-memory and SSD fallback, and many more. So that goes performance, but at the same time we need to have the result correctness. That is very important, and that is also not a trivial thing to do. We use Presto verifier extensively, where our control is today's Java cluster, which is very stable in terms of correctness, and then we run the workload and cross match if the C++ worker have the same results. And the Presto verifier is a tool that this is also in open source, can do these things, that it can identify where a mismatch is and tell us what to fix. And this way we found numerous correctness fixes in Velox, because it's also in its inception, for example, missing mismatch in columns, wrong results, random results, but we eventually matched results with Java worker. At the same time, I understand that this kind of test is heavy because you have to run many queries. It takes time, and you cannot possibly run all queries. So we have a significant investment in fuzzing in Velox side. We have fuzzer in expression evaluation, aggregations, joins, and there are more coming in for exchange and other things that will continue to come to make sure the library is really solid without running very expensive tests. And that has proven very, that make Velox production ready for even bigger and bigger workload. And at the fourth step, we have query banks. So above all of these things, we also have some golden queries. Query banks is classic golden queries, which we think that always need to match, and we also always run through them to make sure, even if all these steps miss something, we do not deviate from what the previous release actually could support. So these are the rigorous 4 steps of correctness that we always do. And from the memory side, we did there is memory allocator is completely redesigned, and there is a lot of work have been done there. Many out of memory issues are resolved, investigated, and resolved. We also implemented cache shrink recently, so that if the worker Velox part is managed with memory allocator, but there are other components like proxygen server, they may have allocation that goes beyond that is unknown to the allocator. In that kind of cases, what can we adjust in the server? Like we can adjust the in-memory cache, so that if someone else outside start allocating more memory, we do not kill the system. And from crash, definitely this is new software. There was sec pulse at the beginning, and we from 30, 40 crashes to no crash. And there are many more features and stability improvement we have done. So, and then the monitoring and security. So we need to we have added the HTTPS support in OSS. We have integration with Proxygen. Proxygen has very good monitoring to understand how many HTTP, the health of the HTTP server. The integration, we also integrated the Velox task and expression logging, and we have many counters for memory management, cache, hit, miss, pushback, shrink, driver performance, driver latency, and we have a whole Presto ecosystem inside Meta. So we integrated with that seamlessly, so that we can maintain and monitor the system as if for anyone who knows Presto can monitor it without knowing if it's a C++ worker or Java worker. And obviously very rigorous release management, how quickly how can we release it every week, and every night we run all these kind of defined tests, and how can we keep the binary moving in production. And for production routing, we initially decided how to do the routing strategy and fallback plan, because we have a completely new Presto worker, which is probably the biggest change since the inception of Presto happened. So we had to replace one Java cluster, but keep the other Java cluster as is, and we have to have some routing mechanism. If the query fails here, we can route it somewhere else. And as soon as we got confidence, we started deploying in all clusters in one region, and then we have deployed in all the other regions also. And we always ensure the deployment and everything is done weekly. This is very important for the company and us to make sure, as an evolving platform like Velox, we can ship it very quickly. And so far we have no issues with this customer. That is one of the biggest customer they have. We have solved a major problem with them, major performance problem for this customer with less hardware, maintaining the SLA that we had with them. Okay. So this chart is some of the representation. So this is there are two horizontal lines. There is a green line, there is a blue line. Green line and blue line, these two lines represents number of hardware, and the curve represents number of queries. And there are, if you and these two, there are 4 colors, so each color represents one region. So if we just see the curves, there are I think red and purple, they represent number of query in 2 regions. So they kind of overlap, meaning the number of queries are same in both regions. And as you see, in one region we have Java, another region we have C++. And as we deploy, you see the number of queries remains same in both regions, but the number of hardware, the blue region, is almost half, almost 1/3. And these are some of the metrics from our production, how the cache behaves. So we have a very good RAM hit rate, and RAM and SSD hit rate is even better. We have monitoring for the errors in cache and how much bytes are cached in the SSD. We have all sorts of monitoring for HTTP server health, HTTP request, in-flight HTTP request, request bytes, response latency, aborts. These are some of the highlights, but there are many more. And some of the important ones from the worker are the driver executor latency, failures, number of hanging tasks, or we call zombie tasks, and maximum number of tasks in execution at some time. So after this, we had to figure out what will be the next path forward, because this is a custom case. We have a fixed set of query, but that is not the entire warehouse. So we want to change the entire warehouse with C++ worker, and that is our end goal, because we cannot keep 2 variants running and release and maintain for a long time. That is a very big price for maintenance. So we have started expanding to more query shapes and long running and write heavy queries, and we want to expand to important dashboards and stabilize the platform for arbitrary workload. So this will battle test Prestissimo and Velox. We have to go to a scenario where the query can run successfully or fail gracefully. We have to make sure the correctness not only for the reads but also writes, and the file layout, metadata, and number of files are almost in same magnitude that the Java worker writes. We have to figure out how to do the non-deterministic, how to handle the non-deterministic queries. One option is to replace part of the query with different functions. And then we want to look for global performance optimizations. We want to test a lot and enhance fuzzer significantly. And as if you follow Velox and Presto CPP, we are changing fuzzer to use Presto eval instead of DuckDB to make sure that the results in fuzzer is verified with Presto eval, just like verifier. And we have to find a plan for non-deterministic queries. So with that, what is our next set of workload? So when we go to the production, we need to pick another big use case that gives us most bang for the bucks. For Meta Warehouse, that is the batch workload that has a significant amount of hardware, extremely CPU intensive, and we plan to cut them by half. So we have 2 major split in batch. Inside the batch itself, there are scheduled workload that can be retriable, that's roughly 60% CPU. There are some ad hoc workload runs in batch, they're roughly 40% of CPU, and there are some templated ad hoc workload. So our first opportunity is to go to the retriable place, because that place, even if we cannot support the query, we can retry somewhere, and we can get this massive CPU reduction, and which means hardware reduction. And we also definitely cannot regress on wall time. And we want to retry quickly, but we don't want to waste compute. For that, the journey is very complex. So we had to rework many things. We had reworked Presto Exchange. So we had made Exchange server a Presto exchange to work to support almost 1,000 workers. And the existing, we have set up the, our goal is to replace 2 batch cluster with 1 batch cluster which is even smaller in size of individual existing cluster. We in memory management, we did the memory augmentation and disk spilling, and we have total and per query memory capacity enforcement, dynamic spill, dynamic memory sharing between running queries. For rollout, we have the dynamic storage location discovery, threshold based spilling, data correctness and verification for spilling, definitely monitoring, and also at the same time when you go with C++ worker, we want to deprecate a legacy legacy query execution mode called large batch mode. If you know about in Presto, there is a way to kind of do persist the intermediate shuffle results. So we want to completely remove that and make sure the spilling can handle those queries. So we have several spilling monitoring, like how much file we are creating, how many bytes we are writing per second, per hour, spilling sorting time, spilling disk file count, and so on. And then we also had in the Velox stack we have reliability. We have already fixed 400 plus bugs and crash fixes. There are 100 plus correctness issues resolved, but there is non-deterministic queries, and there is different functional behavior like JSON parse, regular expression. There are differences and nuances that we have a customer dependency with the existing platform existing Java eval. For example, Java use Yoni for regex, but C++ you have to use RE2, and they are not exactly same. Same for JSON, because in Java, in C++ we use SameD-JSON in Velox, which is fast, but then there are cases when the results are different when the JSON itself is man-formed. So there are a lot of nuances in functional behavior that is going to be changing. And there are obviously, to support this kind of variety of workload, we need many new features. So we added multiple new functions, and community also helped us to add more functions in Velox and signatures in the existing functions. We have invested heavily on worker health to make it reliable, to make sure the zombie tasks, communication crashes, general unhealthy worker and worker communication problems reduces to support these high throughput and high long running queries. So this is where it stands today for batch. It is not in production, but in the green line is, this is from the September to up until today, is percentile on the y-axis. In the green line is the percentile of query that we can support in one region. But the important part is the blue line is demonstrating how much CPU we can support. And as you see, number of query in terms of support, in terms of function is easier, but supporting heavy queries has become harder and harder. So that is something very interesting that we found, and we continue to push boundaries so that we can support heavy queries, so that these two lines kind of handshake at some point, and it works, and we can support high CPU queries. And you see up and downs because the query shapes the concurrency and everything kind of changes every day. So it gives our shadow system a very good dry run before the production, and the trend actually is going upwards. But the important part is, even in these, the CPU performance in Velox platforms remains almost 2 times better, which means the execution time will be better, which means the wall time will be at least similar to what we have or even better, which is very good news, demonstrating the eval is, or this investment is actually going to the right direction. So for reliability, we have worker communication, CPU memory, and the correctness is something we want to emphasize. It's a very hard problem to tackle. There are deterministic errors that we have fuzzer and verifier. For non-deterministic errors, in Velox, there are a lot of work to do custom verification. For example, approx percentile can be compared with percentile and see the deviation. And at the same time, for a query shape that is non-deterministic, we do replacement on the query to see if we can support the query. For example, approx percentile can be replaced with average and see if we can execute the plan or execute the shape of the query at least. And there is the Presto further in coming. And in the query routing side, we need to figure out how can we statically route a query to Prestissimo. And we also, when we go to production, we will build something that certifies a query saying that, okay, this query is ready to run in C++ worker. With that, this is the end. Thanks for everyone in Presto and Velox in Meta and external platform, external partners. We call them one team. And the Meta Experimentation Platform, who is the first use case to run Prestissimo in a large scale production. Thank you.